Okay, welcome to the first video. This is patterns and expressions. And we're going to cover some definitions first. A mathematical quantity is anything that can be measured or counted. The value of the quantity is its measure or the number of items that are counted. Quantities whose values do not change are called constants. In other situations, the value of the quantity can change. Quantities whose values change or vary are called variable quantities. Makes sense because they vary. Variables are a symbol, usually a letter, that represents one or more numbers. For example, we have n and x. A numerical expression is a mathematical phrase that contains numbers and operation symbols. It's just numbers, 3 plus 5. The difference between 8 and 2 and 5. No variables, just numbers. An algebraic expression contains variables. So an algebraic expression is 3n plus 5 or 8x minus 2 plus 5n. So the difference between a numerical expression and an algebraic expression is just that an algebraic expression has variables. Ugh. Okay, so let's do a problem. Look at the figures from left to right. What is the pattern? What would the next figure in the pattern look like? So, how can you identify a pattern? So you look for some type of change between consecutive figures. What's changing between these figures? Right, we're gaining a side. So if these are our shape number, this is shape number 1, shape number 2, shape number 3, and shape number 4. And we want to know what shape number 5 is. So the number of sides for shape number 1 is 3. And the number of sides for shape number 2 is 4. 5 sides for shape 3, and 6 sides for shape 4. So we need to know the number of sides for shape 5. Right, it's going to be 7. But let's figure out how we know, because that's important. So, to get from 1 to 3, what do? Well, there are two mathematical processes we could do. We could say 1 plus 2, or we could do 1 times 3. Either way will get us from 1 to 3. Well, how do we get from 2 to 4? Well, let's look at the same two processes. We could do 2 plus 2, just like we did for 1, add 2, we'd get 4. Or we could times by 3, which is how we got 3. But 2 times 3 is 6, not 4. So that won't work. So we're adding 2 to each shape number to get the number of sides. 3 plus 2 is 5. 4 plus 2 is 6. 5 plus 2 is 7. We are going to have 7 sides, and we've just mathematically shown that. So it's important not just to know the answer, but to know why that's the answer. But what if we had n shapes, which is why we had to figure this part out? If we had n shapes, we couldn't do and say, oh, this just increases by 1, which it did. Because we don't know the difference between 5 and n, so we don't know the difference between 7 and whatever number of sides shape n has. So we're going to fall back on math, and we're going to say, well, each one of these added 2. So to get n, we just add 2. We have n plus 2 sides for the nth shape. Okay, moving on. Tables are a convenient way to organize data and discover patterns. They work much like input-output machine. A machine that takes one value as input, processes it, and gives a value as an output. A process column, right here in the table, provides a way to understand what happens to the input values. So, use a pattern to answer the following. How many toothpicks are in the 20th figure? That's what we're going to answer the question. But we need to do some work to figure out what the process is. So we have figure 1, figure 2, and figure 3. How many toothpicks are in figure 1? These little lines are toothpicks, by the way. We have 1, 2, 3, 4. How many toothpicks are in figure 2? 8. Good. How many toothpicks are in figure 3? 12. Great. Now, let's figure out how do we get from 1 to 4? Well, we could add 3. That worked on our last example. But 2 plus 3 is not 8. So that's not right. How else could we get from 1 to 4? Well, we could do 1 times 4 is 4. Does that work for 2? Yes, yes it does. Great. So to get the output, multiply the input by 4. So our process column is going to look like this. 1 times 4 equals 4. 2 times 4 equals 8. 3 times 4 equals 12. N times 4 equals 4n. So for our nth figure, we have 4n toothpicks. So what's our pattern? Our pattern is to multiply the figure number by 4 to get the number of toothpicks. So now we're going to work on answering our question. How many toothpicks are in the 20th figure? There are 20 times 4, which is 80 toothpicks in the 20th figure. Process columns are really good because you're frequently going to be asked about the nth term. Okay, here's something else you could encounter. Identify a pattern and find the next 3 numbers in the pattern. So we have 3, 6, 10, 15. How do we get from 3 to 6? And then from 6 to 10? Then from 10 to 15? This time they don't all have to match, but we have to figure out a pattern. So let's look at this. How could we go from 3 to 6? Well, we could do 3 times 2 is 6. And we could say 3 plus 3 is 6. Okay, great. Now let's look at 6 and 10. How do we get from 6 to 10? To multiply, we'd have to multiply by 5/3 to get 10. That's kind of unpleasant. Or we could do 6 plus 4 is 10. None of those are the same, so we are going to have a pattern. Let's look at 10 to 15. Ugh. We'd have to go 10 and multiply it by 3/2 to get 15. Ugh. Then we could do 10 plus 5 is 15. So let's see. Is there a pattern? Well, we can multiply by 2, 5/3, 3/2. I don't think there's a pattern there. And then we could also have 3, 4, 5. Hey, that's a pattern. So there's your pattern. We add 3, we add 4, we add 5. So we're going to add 6 and get 21. Then we're going to add 7 and get 28. And then we'll add 8 and get 36. It's important to note that when we're doing this sort of problem, you don't have to worry about n. This one, you just got to figure out what the pattern is. Okay. Our final question. Identify a pattern in the graph by making a table and include the process column. What? A graph? Well, it's all right. Which one is the input? Oh, that's over here. Your X is going to be your input, which means your Y is your output. This is not as hard as it originally looks because you say, okay, for the input that's 1, our output is 6. For the input that's 2, because we just look at these little points, the output is 7. Okay, what about the input is 3? Okay, find 3 on the input. Our output is 8. And here our input is 4, our output is 9. And for 5, our output is 10. Well, that's great, but now we have to find n. Well, how did we go from 1 to 6? 1 plus 5 is 6, or 1 times 6 is 6? 2 plus 5 is 7, 2 times 6 is 12. So I think we're just going to go with the plus 5. So we have 1 plus 5 is 6, 2 plus 5 is 7, 3 plus 5 is 8, 4 plus 5 is 9, 5 plus 5 is 10, n plus 5 is n plus 5. So our output for n is n plus 5. It didn't really fit in the little box there. Okay, that's it for 1.1. Continue on with 1.2.